Hello everyone, welcome back to the channel Code with AKJ where we solve daily coding challenges to sharpen up our problem solving skills. Today is day 33 of solving Geeks or Geeks problem of the day and today's question is minimize the heights too. So the question says here given an array ARR denoting heights of n towers and positive integer k. For each tower you must perform exactly one of the following operations exactly once. Here increase the height of the tower by k or decrease the height of the tower by k. Find out the minimum possible difference between the height of the shortest and tallest towers after you modified each tower. So note here is that it is compulsory to increase or decrease the height of k of each tower, and after the operation the resultant array should not contain any negative integers. So here the problem goes like this. You are given an array of integers that represents the height of towers. For each tower you can either increase or decrease its height by a fixed value k. Here the task is to find the minimum possible difference between the tallest and shortest tower after performing these operations. So for example, the given k value 2 and array 1, 5, 8, 10. After modifying the heights, the minimized height would be 5. So let's start with the brute force approach. So for each tower, we can either add or subtract k. So we need to try all the combinations to find the smallest difference between the tallest and shortest towers. So the steps here would be to check all the combinations, and for each element we can either add k or subtract k. So we'll generate all the possible height combinations, and since here the n value is 4, the possible combinations would be 2 power n, which is 2 power 4 and 16. So here I have written all the possible combinations and in the form of binary format where 0 represents subtraction and 1 represents addition. So let's dry run this. So here in this given array, the first combination would be 0, 0, 0, 0, which means we need to subtract the k value from each and every tower. So after subtracting k value from each and every tower, the values would be -1, 3, 6, and 8. So the difference between the largest and the shortest tower would be 9 here. The same goes with 0, 0, 0, 1. Here 1 represents addition, so which means we need to add k to the first element and rest would be subtracted. So here in this case, adding k to the first element would be 3 and remaining subtracting 2 from each and every element would give us 3, 6, and 8. So in this case, the difference between the largest and shortest tower would be 8 and 3, which is 5. Same goes with third case, which is adding k value to the second element and rest would be subtracting by k, which gives -1, 7, 6, and 8. In this case, the difference would be 9, and the fourth case, the difference would be 5, and so on and so forth. By using these combinations, we'll add or subtract k to each and every element and we'll find the differences between them and we'll take the minimum out of all this. So after analyzing all the possible combinations, we can observe that only two cases will give us the minimum difference, which would be 0001 and 0011, which means adding k to the first element and remaining elements would be subtracted by k, and adding k value to the first two elements and remaining elements subtracted by k. So these will be the two cases which will give us the minimum difference between the largest and smallest tower. So in this case, our answer would be 5. So we return 5 from the main function here. And since we are trying all the combinations from this given array, the time complexity here would be O of 2 power n and space complexity would be O of 1 as we are not using any external space. So the brute force solution here is inefficient, especially for larger inputs. So now let's optimize it by focusing on sorting the array and making intelligent height adjustment. So the idea here is to minimize the difference between the tallest and shortest stars by either increasing the smallest star or by decreasing the largest star. So once the array is sorted, we'll adjust the first and last elements as well as considering internal elements for adjustments. So here the steps would be to sort the array first and then we'll iterate over the array by increasing the smallest star and decreasing the largest star. We'll calculate the current difference and we'll update the difference by taking the minimum of it. So here I have taken an array 1, 5, 8, 10 with fixed value k value 2. Initially our minimum value would be 1 and maximum value would be 10 and current difference would be 9. So we'll iterate over this array and we'll start with index 1. As we need minimum value, so initially we'll add k to the minimum value and the current value would be deducted by k value as the array is sorted, and since we move from left to right the values would be larger and we need to take the minimum of both. So we'll deduct the k value from the current element. And as we need maximum value, here the initially maximum value would be deducted by k and the current previous element would be added by k. So by using these two steps, we'll update the maximum and minimum value by iterating over this array. And here's the dry run approach. For I equals to 1, the minimum value would be 1 plus 2 and 5 minus 2, and the minimum of both 3 and 3 would be 3. And maximum value here would be, initially the maximum value would be deducted by k value, which is 10 minus 2, and the current element would be added by 2. So here the maximum between 8 and 3 would be 8, and the current difference here would be 5, and the main difference would be the difference between 9 and 5, which is 5. The same goes with I equals to 2, I equals to 3, and so on and so forth until we reach the end of the array. So by using these two steps, we'll calculate the current difference between the towers by adjusting the height of it, either by increasing it or by decreasing it. So in this way, we'll calculate the minimum difference between the towers by either increasing the tower by value k or by decreasing the tower by value k. So let's code this approach and let's submit it. So this is the code for the optimized approach we have discussed. Here I have taken the size of an array in the form of n, and this is the base case. If the size of the array is 1, we'll return 0. We'll sort the array for the easy processing of smallest and largest towers. Initially the difference would be the last element and the current element. Here I have initialized the maximum and minimum tower value, which is the last element and the current first element. We'll run a loop starting from index 1, and this is the base case where if at any point the difference would be negative, we'll skip that part as a note mentioned here, and we'll use these two steps to calculate the maximum and minimum tower by doing the operation adding or deducting the k value from the current tower, and we'll calculate the current difference and we'll update the main difference by taking the minimum of both. So finally we'll return the main difference here. So let's try to compile and run this. So let's submit. As you can see, this problem got solved successfully. Here the time complexity would be O of n log n and the space complexity would be O of 1. So since we used sort function, the space time complexity would be O of n log n, and since we didn't use any external data structure, the space complexity would be O of 1 as our expected time complexity and space complexity. We tackled this problem using greedy approach, and I hope you like this video and explanation. If so, please give it a like, share with your friends, and subscribe to my channel for more such coding challenges. Keep coding, and thank you.